Hi, Steve here from Green Marine Lithium. Today I just want to talk a bit about wiring and crimping. Obviously in our factory here we use automatic wiring and crimping machines. What that does is make sure that we strip a wire perfectly and they crimped perfectly and consistently. However, lots of installers and people in the field use these sort of tools. So we're going to give a few tips today about what not to do and how important things are. So this is some wire that we use here in the factory. I'll just strip this off. Now this is marine tinned cable. I don't know if you can see that or not, but it's multi-core cable. It's all it's tin plated copper, and this is DC cable, good quality DC cable. Now this here is your common household cable. So this is AC cable. As you can see, it has multi-core. This is a multi-strand actually, but they're not tin coated copper, so they'll corrode. And as you can see with this marine cable, it's very flexible. This cable here is very rigid. Now the reason being is when this gets installed in your wall on your house and the roof and ever, it just gets installed. It doesn't move around. It doesn't go 100 kilometers an hour. It doesn't go over cattle grids, and it doesn't hit waves, and it doesn't sit in the water in the sun. It sits in your house for 10 years and never moves, and carries 10 to 20 amp max, AC 240 volt. That's all it does. Now, the reason you don't want to use this in your boat is a couple of reasons. One, obviously it's not tin, so it's going to corrode very, very, very quickly. Like within 12 months, that'll be corroded. Secondly, it's not flexible in the sense. Now, if we just pull off one of these strands, if you give it a few wiggles, this is brand new cable, it breaks straight off. Now, let's just say this is 10 amp cable. Let's just say there was 10 strands in there. So that means each strand would carry potentially one amp of current. Now that you've removed one of those, you've actually reduced the capacity of this wire. Now, that's part of the reason what will happen in boats. Obviously, boats bounce around a lot on a trailer, hit a pothole, whatever. And if this is connected to something and it gets all that movements, on top of that, it's corroded, it breaks off, and that's when you have troubles. Now, using marine cable, now this is 4AW, so it can carry quite a lot of current. So that's why it's bigger. However, it's tin copper, and as you can see here, you can wriggle this till the cows come home, and it's not going to come off. There's tiny little strands of multi-copper. Now, that also helps with heat dispersion, because cables, believe it or not, when they're mounted in your boat, and you should mount them in the boat so they don't move, when they're mounted in your boat, they need airflow around them to cool down. You don't want to get all these cables, get some electrical tape, bound them together tightly, because they're both getting each other hot. Secondly, I mean, you don't want to use that in your boat anyway, because if this cable breaks and cuts into this one, you've got a bundle of cable electrified, catching on fire, which sort of causes the problem. But what you should always do is, obviously, we recommend crimping it, putting a lug on there, depending on what sort of connection, and then heat shrinking it to cover it. Some people actually solder the top when it's in a lug. I'll show you one up here actually, just to seal the ends of it. I don't like to use solder because it's not very flexible. Yeah, sometimes they put a little bit of solder in the end there. Proper crimping, don't put it in a vise, don't use a chisel and a hammer to flatten it or whatever. You need a crimping tool. Obviously that's a big crimping tool. These crimping tools here, if you look at the color code of your crimp, I've got one here. Here's a blue one. So blue is for blue, red's for red, yellow's for yellow. You'll see the three colors. One thing you don't want to do, and I think we've all probably done it in our time, if we go to, say, we'll strip this wire here, and we'll actually cut too far in. So when we pull it off, we've pulled off half the cable, and I'll just show you that. Made a bit of a mess here. But you can see half the cable's missing. Now what you've actually done there is reduce the capacity of the cable. So if that piece of cable then gets connected into there, it's got half the amount of capacity it's designed for. So if you make a mistake like that, cut it off, do it properly. It might take you an extra minute, but it's worth it in the long run. You especially don't want to do that with this type of cable either. Now, because this cable is so rigid, it's difficult to put into connectors. It's not designed to go into a this type of crimp thing because it'll just slide straight out. We see this a bit, not as much as we used to in boats. The reason I think people use this cable here is because it's $1 a meter versus say $20 a meter. It's cheaper, but you know, over wiring your boat, if you'd saved a couple of $100, but you know it's always going to be safe versus saving a couple of $100 and knowing your boat's going to have an electrical issue within 12 months. I mean, it's a no-brainer which way you should go. So same old story. Always use an isolator. Always use a fuse. Always use the right size marine grade tin copper cable. Now the way you calculate that is two things. Obviously the max amp rating to whatever appliance you connect it to needs to marry up, and also the length of the cable. So the longer the cable, the thicker you have to get the cable to send, say, 50 amps. So a 5 meter cable that needs 50 amps to run a trolling motor versus a 1 meter cable, it'll be a bigger cable for the longer distance. But there's plenty of online calculation tools that you can just punch in what your compliance is saying. And look, if you don't know where it is, look at the specification sheet. This is obviously a 240 volt, but it says you there all the maximum volts, watts, current, everything else. So you've got the information on the appliance. Of course, you've got to match it up to your battery as well. But yeah, hopefully this has been a little bit of helpful information about wiring and why we use tin copper multi-core cable versus multi-strand AC cable, and the importance of crimping, wire stripping, using the right tools. But we always recommend going to a trained boat installer to install any of your appliances. Nowadays you can get $20,000 or $30,000 worth of electrical gear easily on a boat, so it's important to look after it, make sure you provide clean power to the device, and you'll have no problems.